From a stadium that will host one of the world's biggest sporting events to man-made islands for the ultra-wealthy, and from a rail network connecting an entire nation to a river that doesn't exist in nature, these are some of the most ambitious megaprojects transforming the Arab world. Starting with, after 5 failed attempts to host the World Cup, Morocco finally won the hosting rights for the 2030 World Cup, making history as the second African nation to host football's biggest competition after South Africa in 2010. And Morocco isn't content with just participating. The country wants to deliver a World Cup that will be remembered for generations. The first part of the deal is the modernization of Morocco's football infrastructure, and the country is spending billions to achieve just that. The key cog in this infrastructure push is a stadium named after King Hassan II, the ruler of Morocco from 1961 to 1999, and was instrumental in modernizing the country. The stadium will be built in Ben Slimane, a city about 60 kilometers northeast of Casablanca, strategically located between Morocco's economic capital and the airport. With a planned capacity of 115,000 spectators, it will become the largest football stadium in Africa and one of the largest in the world, surpassing even Barcelona's iconic Camp Nou. The project was officially announced in 2023, straight after Morocco's bid to co-host the World Cup was confirmed by FIFA. The Moroccan government immediately began assembling a team of international architects and engineers to design a stadium that would showcase both Morocco's rich cultural heritage and its modern ambitions. The design incorporates traditional Moroccan architectural elements, geometric patterns inspired by Islamic art, materials that reference the country's historic buildings, and a color palette drawn from Morocco's landscapes. Construction officially began in late 2023, with initial work focusing on the massive foundation required to support a structure of this scale. The site required extensive preparation, including soil stabilization and the creation of underground infrastructure for utilities, parking, and service areas. The stadium's foundation alone required hundreds of thousands of cubic meters of concrete, poured over months of intensive work. The construction timeline is tight. The stadium must be completed by early 2029 to allow time for testing and FIFA inspections before the 2030 World Cup. This gives Morocco roughly 5 years from groundbreaking to completion, an aggressive schedule for a project of this magnitude. As of early 2026, the foundation work is complete and the stadium's structural frame is beginning to rise above ground. Steel and concrete work is progressing on schedule, with thousands of workers on site daily. The stadium's design is remarkable not just for its size, but for its innovation. The roof structure will be one of the largest in Africa, providing shade for spectators while allowing natural ventilation, crucial in Casablanca's warm climate. The stadium will incorporate modern amenities, including VIP suites, premium seating areas, world-class hospitality spaces, and cutting-edge broadcast facilities that meet FIFA's strict requirements for World Cup venues. But the Hassan II Stadium is only part of Morocco's massive football infrastructure investment. The country is simultaneously renovating 6 existing stadiums across major cities: Agadir, Casablanca, Fez, Marrakesh, Rabat, and Tangier. This renovation program carries an additional budget of approximately $1 billion, bringing Morocco's total World Cup infrastructure spending to around $2 billion. The 2030 tournament represents not just a sporting event, but validation of Morocco's development and its position as a stable, modern nation capable of hosting the world's biggest sporting event. The government views this $2 billion investment as money that will pay dividends for decades through tourism, international prestige, and improved sports infrastructure that Moroccan citizens will use long after the World Cup ends. The renovations to the 6 existing stadiums are substantial projects in themselves. In Rabat, the Prince Moulay Abdallah Stadium is being completely rebuilt with a new capacity of 50,000. In Marrakesh, the Grand Stade de Marrakech is being expanded and modernized. Casablanca's Mohammed V Stadium, one of Morocco's most historic venues, is receiving a complete overhaul while maintaining its iconic status. Each renovation must meet FIFA's strict standards for World Cup venues while also serving the needs of local football clubs and fans. The economic impact of these projects extends far beyond construction. Tens of thousands of jobs have been created, not just for construction workers, but for engineers, architects, planners, and suppliers. Moroccan companies are gaining experience with world-class infrastructure projects, building expertise that can be applied to future developments. The improved stadiums will also boost Morocco's domestic football league, providing better facilities for local teams and potentially attracting international tournaments and matches. There's also a broader regional significance. Morocco is positioning itself as North Africa's sports hub, competing with countries like Qatar and the UAE that have invested heavily in sports infrastructure. Success with the 2030 World Cup could lead to Morocco hosting other major events, perhaps the African Cup of Nations, international athletics championships, or even a future Olympics bid. The construction of Hassan II Stadium and the renovation of 6 other venues represents Morocco's largest ever sports infrastructure program. Whether Morocco can complete this ambitious program on time and on budget will be tested over the next 4 years, but current progress suggests the country is determined to make this home World Cup a success that transforms Moroccan football forever. As massive as the new stadium is, the upcoming megaprojects will become 10 times more extreme, starting with a water crossing in Qatar's capital that is no short of an engineering marvel. Doha sits on a peninsula extending into the Persian Gulf. The city has grown explosively over the past few decades as Qatar's oil and gas wealth has transformed it from a small trading port into a gleaming modern metropolis. But this rapid growth created a massive problem. Doha Bay cuts through the heart of the city, and currently, there are only 2 ways to get from one side to the other: the Corniche Road that goes all the way around the bay, or the Al Rayyan Road that skirts the southern edge. During rush hour, what should be a quick 5-minute journey can take over an hour. Traffic congestion costs Doha's economy hundreds of millions of dollars annually through lost productivity, wasted fuel, and reduced quality of life. The Shark Crossing project will solve these problems with not 1, but 3 separate crossings spanning Doha Bay, creating a massive transportation corridor that will reshape the entire city. The centerpiece is a cable-stayed bridge that will become one of Qatar's most iconic structures. But recognizing that a single bridge wouldn't be enough to handle Doha's traffic, the project also includes an immersed tube tunnel running beneath the bay and a land crossing that will connect different parts of the coastal road network. Qatar first began seriously studying options for crossing Doha Bay in the early 2000s as the country prepared to host the 2022 FIFA World Cup. The tournament would bring millions of visitors to a city whose infrastructure was already struggling with congestion. Initial proposals focused on a single bridge, but engineering studies revealed that Doha Bay's depth, the soft seabed conditions, and the need to maintain shipping access meant a more comprehensive solution was needed. The current 3-crossing design was finalized around 2017, with detailed engineering studies conducted over the following years. The project was officially approved and funded in 2019, with construction scheduled to begin in 2020. However, the COVID-19 pandemic delayed the start, and groundwork didn't actually commence until 2021. The cable-stayed bridge represents the most visible element of the project. Rising over 200 meters above the water, the bridge will feature distinctive towers that will become new landmarks on Doha's skyline. The design draws inspiration from both modern engineering and traditional Qatari architecture, with towers that reference the shapes of dhow sails, the traditional boats that have plied these waters for centuries. The bridge will carry 8 lanes of traffic, plus dedicated lanes for public transit, along with pedestrian walkways that will offer spectacular views across Doha Bay. Building the bridge foundations in Doha Bay presents significant challenges. The seabed consists of soft marine sediments that require deep piling to reach stable bedrock. Each of the main towers sits on massive foundations that extend 50 to 60 meters below the seabed. The construction process involves driving hundreds of steel piles, then creating enormous concrete caissons that will support the tower structures. This work must be done while maintaining shipping access to Doha's port and minimizing environmental impact on the bay's marine ecosystem. The immersed tube tunnel takes a completely different engineering approach. Rather than spanning above the water, this tunnel will run beneath the bay in prefabricated concrete sections. Each section is built on land, floated into position, then carefully lowered to the seabed where it connects to the previous section. The tunnel will eventually stretch over 3 kilometers with multiple lanes for traffic, plus emergency exits and ventilation systems. Immersed tube tunnels are complex but proven technology. Similar tunnels exist in places like Hong Kong, Copenhagen, and South Korea. As of early 2026, construction is well underway on all 3 crossings. The bridge's main towers are rising above the water, with pile driving and foundation work complete. The tunnel sections are being fabricated in purpose-built yards, with the first sections already installed on the seabed. The land crossing component is progressing fastest, as it involves more conventional road construction techniques. The $12 billion budget makes this one of the most expensive infrastructure projects in Qatar's history, exceeded only by the massive investments in World Cup stadiums and the Doha Metro. But unlike World Cup stadiums, which see limited use after the tournament, the Shark Crossing will serve Doha's residents and economy for decades to come. The project is being funded entirely by the Qatari government through its Public Works Authority, with major international construction firms leading the work alongside local contractors. Once complete, the new crossings will cut travel times dramatically. A journey that currently takes 45 to 60 minutes during rush hour will be reduced to 10 to 15 minutes. This will open up new areas for development, as neighborhoods that were previously too far from job centers become practical places to live. The project will also reshape Doha's urban development patterns. Areas on the western side of Doha Bay that have remained underdeveloped due to poor connectivity will suddenly become prime real estate. Qatar's government is already planning major mixed-use developments in these areas, anticipating that improved access will drive demand. The increased connectivity will also make Doha more attractive to international businesses and expatriate workers, supporting Qatar's broader economic diversification goals. The completion timeline targets 2028 for the first crossing to open, with all 3 crossings operational by 2030. This would represent roughly 9 years from initial construction start to full completion. If Qatar meets this schedule, the Shark Crossing will transform Doha just as the city continues growing as a regional hub for business, culture, and tourism. While the country gained global attention through the World Cup, projects like this demonstrate Qatar's focus on building the foundations of a modern, efficient city that can compete with Dubai, Abu Dhabi, and other regional capitals. When completed, the crossing will stand as one of the Middle East's most impressive transportation megaprojects, a $12 billion solution to a problem that has frustrated Doha's residents for decades. From one of the most delayed water crossings, we move over to Egypt and to one of the fastest completed megaprojects in history. Every day, dozens of massive container ships queue in the waters off Egypt, waiting their turn to transit through one of the world's most important waterways. The Suez Canal, connecting the Mediterranean Sea to the Red Sea, handles about 12% of global trade. But in 2013, Egypt faced a crisis. The canal was approaching capacity, ships were waiting days for transit, and Egypt risked losing business to alternate routes. The original Suez Canal opened in 1869 after 10 years of construction that cost 100,000 Egyptian workers their lives. The 193-kilometer waterway instantly became one of the world's most strategic assets, cutting 7,000 kilometers off the journey between Europe and Asia by eliminating the need to sail around Africa. Control of the Suez has sparked wars, international crises, and diplomatic standoffs. Egypt earns over $8 billion annually from canal transit fees, making it one of the country's most important sources of foreign currency. By the early 2000s, the canal faced serious capacity constraints. Ships were getting bigger. Modern container ships can carry over 20,000 containers, making them too large to pass each other in much of the canal. This meant the canal operated like a one-way street, with convoys of ships heading south in the morning and north in the afternoon. If ships arrived at the wrong time, they waited in holding areas for the next convoy, sometimes for days. As global trade grew, These delays became more frequent and longer. In August 2014, Egypt's president Abdel Fattah el-Sisi announced a solution that was audacious: build a second Suez Canal. Rather than a typical government infrastructure project with years of planning and international financing, el-Sisi announced that Egypt would build a 72-kilometer parallel channel in just 1 year, funded entirely by Egyptian citizens through investment certificates. The announcement was met with widespread skepticism. How could Egypt possibly dig 72 kilometers of canal in 12 months when the original Suez took a decade? But el-Sisi was serious. Within days, Egypt launched a massive public fundraising campaign, selling investment certificates to citizens. Incredibly, Egyptians purchased $8 billion worth of certificates in just 8 days, demonstrating both patriotic fervor and confidence in the project. With funding secured, Egypt mobilized on a scale unseen since the construction of the Aswan High Dam in the 1960s. Construction began immediately in August 2014. Rather than starting from scratch, the plan called for expanding and deepening an existing parallel channel in the northern section of the canal while digging an entirely new 37-kilometer section in the southern part. This approach reduced the total amount of excavation required while still achieving the goal of allowing two-way traffic. The scale of the operation was staggering. Egypt deployed 17 international dredging companies, operating 27 dredgers, working 24 hours a day. The companies came from Belgium, the Netherlands, and Egypt itself. Over 1,000 smaller vessels supported the dredging operations. On land, construction equipment manufacturers shipped in some of the world's largest excavators and dump trucks. At peak construction, over 35,000 workers were on site, digging through sand and rock under Egypt's brutal summer sun. The logistics were enormously complex. The dredgers removed roughly 250 million cubic meters of sand and rock, enough to fill 100,000 Olympic swimming pools. This material couldn't just be dumped randomly. It had to be moved to designated areas where it wouldn't block shipping lanes or damage marine ecosystems. Fresh water had to be brought to the desert work sites. Workers needed housing, food, and medical facilities in areas with virtually no existing infrastructure. Engineers faced specific technical challenges unique to the Suez. Unlike rivers or harbors where you're dredging relatively stable sediment, the Suez Canal cuts through areas where the seabed can shift. The canal banks had to be carefully engineered to prevent collapse, especially in areas where the new channel ran parallel to the old one, with only a narrow strip of land between them. In some sections, the canal bottom lies below sea level, requiring constant pumping to prevent flooding of work areas. Remarkably, Egypt completed the project in just 11 months. In August 2015, almost exactly 1 year after the announcement, President el-Sisi inaugurated the new Suez Canal in a lavish ceremony attended by foreign dignitaries and broadcast live across Egypt. The opening was treated as a national triumph, demonstrating Egypt's ability to execute a major infrastructure project on an accelerated timeline, while other countries struggled with delayed megaprojects. The new Suez Canal fundamentally changed how the waterway operates. The parallel sections now allow ships to transit in both directions simultaneously, effectively doubling capacity in those stretches. Transit times dropped from 18 to 20 hours to 11 to 13 hours for a complete passage. The number of ships that could transit daily increased from 49 to 97, though actual daily traffic averages around 60 to 70 ships depending on global trade volumes. Economically, the results have been mixed. Egypt projected that canal revenues would increase to $13 billion annually by 2023, but actual revenues have grown more slowly, reaching around $9 to $10 billion by 2024. However, the project delivered benefits beyond just revenue. The faster transit times made the Suez more competitive against alternatives like the Cape of Good Hope route. The expanded capacity gave Egypt room to grow as global trade increases. The project also had unexpected benefits for Egypt's construction sector. The experience gained building the new Suez Canal on such an accelerated timeline has been applied to other megaprojects, including the new administrative capital and various road and bridge projects. The new Suez Canal remains one of the fastest megaprojects ever completed at this scale. Today, ships continue transiting the Suez Canal just as they have for over 150 years. But now, they can pass each other in sections that were previously one-way bottlenecks. From Egypt, we move over to Dubai, to a megaproject that mimics the world map on an island. From the air, it looks like someone tried to recreate planet Earth in miniature and dropped it just off Dubai's coast. The world is one of the most ambitious and troubled artificial island projects ever attempted. 300 islands arranged to form a map of the world, each island representing a different country or region. With an estimated total investment of $14 billion, the world was supposed to become the ultimate symbol of Dubai's ambition. Instead, it became a cautionary tale about what happens when ambition meets economic reality. The story of the world begins in the early 2000s during Dubai's unprecedented real estate boom. The Palm Jumeirah, Dubai's first artificial island project shaped like a palm tree, was already under construction and generating enormous excitement. Sheikh Mohammed bin Rashid Al Maktoum, Dubai's ruler, wanted something even more spectacular. The idea emerged: create an archipelago of islands shaped like a world map, visible from space, where wealthy buyers could own their own private island country. Nakheel, the government-owned developer behind the Palm projects, received the contract to build the world. The project was announced in 2003 and immediately captured global attention. The concept was brilliantly simple and mind-bogglingly complex. Dredge sand from Dubai's shallow coastal waters and use it to create 300 islands arranged to match the continents, all contained within a 9-kilometer by 6-kilometer area. Each island would be sold to private buyers who could develop them however they wished: luxury resorts, private estates, entertainment venues, anything imaginable. Construction began in 2003 with a fleet of dredgers working around the clock. The process involved sucking sand from the seabed and spraying it into carefully designed shapes marked by GPS coordinates. Creating the world map required extraordinary precision. Each island had to be positioned exactly right for the overall shape to work. The islands ranged from 14,000 to 42,000 square meters, large enough for substantial development but small enough to maintain the world map appearance from above. By 2008, the islands were complete. Aerial photographs showed a clearly recognizable world map floating in the Persian Gulf. Nakheel had succeeded in creating a world map from 321 million cubic feet of sand. Protective breakwaters surrounded the archipelago to prevent erosion, and channels between islands allowed boat access. Nakheel began selling islands, with prices ranging from $15 million to $45 million, depending on size and location. The company projected that all islands would be sold within months. Initial sales were strong. Richard Branson's Virgin Group purchased Great Britain. Investors from around the world lined up to buy their dream islands. Development plans included a luxury resort on Antarctica, private celebrity estates on various European islands, and an Africa-themed entertainment complex. Dubai's real estate market was at its absolute peak, with property values doubling every year. Nothing seemed impossible. Then came 2008. The global financial crisis hit Dubai's real estate market like a tsunami. Property values collapsed overnight. Credit dried up completely. Investors who had committed to purchase islands suddenly couldn't secure financing. Development projects that existed only on paper were abandoned. Nakheel itself faced financial collapse and had to be bailed out by the Abu Dhabi government. The world became a ghost archipelago. Of 300 islands, only a handful saw any development. The rest sat empty, barren sand islands slowly eroding under the waves. The protective breakwaters proved insufficient to prevent natural forces from reshaping the islands. Aerial photographs from 2010 showed the islands already losing definition, with channels between islands filling with sediment and island shapes becoming less distinct. The problems went beyond just economics. Environmental concerns emerged about the project's impact on marine ecosystems. The massive dredging operations had disturbed seabeds and altered coastal water flows. Some marine species that once thrived in the area disappeared. Water quality between the islands deteriorated as circulation decreased. Critics who had been silenced during the boom years now questioned whether such massive artificial island projects were sustainable or advisable. Yet the world didn't die completely. A few islands actually were developed. Lebanon Island features a private beach club. Sweden Island has luxury villas. The Heart of Europe project, a cluster of islands designed to resemble European destinations, actually proceeded with development and opened phases, including islands themed after Germany, Sweden, Switzerland, and Monaco. These developed islands demonstrate what the world could have become if the financial crisis hadn't intervened. Starting around 2015, as Dubai's economy recovered, there were renewed efforts to revive the world. Nakheel invested in strengthening the breakwaters and conducting maintenance on the undeveloped islands to prevent further erosion. New sales efforts began, though actual construction remained limited. The challenge is that developing a private island is extraordinarily expensive. Beyond the purchase price, owners must build all infrastructure from scratch: power generation, water desalination, sewage treatment, boat docks, and whatever buildings and facilities they envision. There's no shared infrastructure. Each island is entirely self-contained. This makes even modest development cost tens of millions of dollars, putting it beyond all but the wealthiest buyers. And those buyers increasingly have other options. Dubai's real estate market has matured with plenty of ultra-luxury alternatives that don't require building from nothing. As of 2026, the world remains a peculiar mix of ambition and abandonment. Aerial photos show the world map is still recognizable, though less defined than when first built. 10 to 15% of islands show signs of development or active construction. The rest sit empty, waiting for buyers who may never come. The total investment in the world is estimated at $14 billion, including the initial construction, ongoing maintenance, the developed islands, and infrastructure. This makes it one of the most expensive real estate developments in history relative to what actually exists. Today, the world stands as a monument to a specific moment in Dubai's history, the mid-2000s, when anything seemed possible and no project was too ambitious. Whether it will ever be fully developed as originally envisioned remains doubtful. The story of Etihad Rail begins with a problem. The UAE's 7 emirates, Abu Dhabi, Dubai, Sharjah, Ajman, Al Quwain, Ras Al Khaimah, and Fujairah, were connected only by highways that were becoming increasingly congested. Millions of people drive daily between emirates for work, with the Abu Dhabi-Dubai corridor alone seeing over 350,000 daily commuters. Freight trucks clog the highways, carrying everything from construction materials to consumer goods between ports and cities. The UAE needed a solution that could handle both passengers and cargo efficiently. The concept of a national rail network had been discussed since the 1990s, but serious planning began in 2008. The UAE government recognized that its Gulf neighbors, Saudi Arabia, Qatar, and others, were developing rail networks, and the long-term vision included connecting these networks into a Gulf-wide system. In 2009, the UAE established Etihad Rail as a government company specifically to develop, construct, and operate the national railway network. The project was designed in 3 phases. Phase 1 would focus on freight, connecting the Shah and Habshan gas fields in Abu Dhabi's interior to the port at Ruwais. Phase 2 would extend the network to connect all 7 emirates, linking Abu Dhabi, Dubai, and the Northern Emirates. Phase 3 would extend to the Saudi Arabian border in the west and the Omani border in the east, enabling international connections. The total network would span approximately 1,200 kilometers, with 900+ kilometers of new track and connections to existing infrastructure. Construction on Phase 1 began in 2010, focusing on the 264-kilometer freight line. This was a practical starting point. The UAE's oil and gas industry needed efficient transport for sulfur granules produced as a byproduct of gas processing. Trucks were expensive, slow, and environmentally problematic. A dedicated freight railway could move massive quantities more efficiently. Phase 1 was completed in 2016 and immediately began operations. But Phase 2 represented real ambition. This 605-kilometer section would connect Abu Dhabi to Dubai and to the Northern Emirates, including both freight and passenger service. Planning and design work for Phase 2 took years, as the route needed to navigate through existing urban areas, cross challenging terrain, and connect to ports, airports, and industrial zones. The final route was optimized to serve both freight customers and future passenger traffic while minimizing environmental impact and land acquisition challenges. Construction on Phase 2 officially began in 2018, with multiple contractors working on different sections simultaneously. The scale of the work is enormous. The route requires over 50 bridges, several tunnels through mountains, and careful navigation through environmentally sensitive areas. The track is being built to handle both passenger trains traveling at up to 200 kilometers per hour and heavy freight trains carrying containers and bulk cargo. By 2022, significant progress was visible across the network. The section connecting Abu Dhabi to Dubai was taking shape, with bridges rising across wadis and highways. In the Northern Emirates, track laying was underway. The Fujairah connection, which requires tunneling through the Hajar Mountains, presented particular engineering challenges, with workers boring through solid rock to create passages for the trains. As of early 2026, Etihad Rail has announced that Phase 2 is approximately 85 to 90% complete, with the first passenger services targeted to begin later in 2026. The freight network is already operational on completed sections, with trains moving containers between industrial areas and ports. The final track connections, signaling systems, and station construction are ongoing, with the full network scheduled for completion and passenger operation by late 2026 or early 2027. The passenger service will connect 11 cities across the UAE. Trains will travel at speeds up to 200 kilometers per hour, cutting the Abu Dhabi to Dubai journey to about 50 minutes compared to 90+ minutes by car during typical traffic. The Abu Dhabi to Fujairah route, which currently takes 2+ hours by car through mountain roads, will take about 100 minutes by train. Stations in major cities like Abu Dhabi and Dubai are being designed as architectural landmarks with modern facilities including business lounges, shopping areas, and seamless connections to other transportation modes like metros and buses. The goal is to make train travel the preferred option rather than just an alternative. For daily commuters, business travelers, and tourists, this represents a dramatic improvement in travel times and comfort. Etihad Rail has projected that by 2030, the network will handle 36.5 million passengers annually. The project will also handle significant freight volumes, potentially moving 60+ million tons of cargo annually, reducing the number of trucks on UAE highways and cutting transportation emissions. The $14 billion total cost makes this one of the UAE's largest infrastructure investments, but its impact outweighs the financial toll. When Etihad Rail begins full passenger operations in 2026 to 2027, it will be the first time in the nation's history that people can travel between Emirates by train. For a country built on automobiles and highways, this represents a fundamental shift in transportation culture. The completion of Etihad Rail will also enable the broader GCC Railway project, which envisions connecting all 6 Gulf Cooperation Council countries, Saudi Arabia, UAE, Qatar, Kuwait, Bahrain, and Oman, into a single 2,000+ kilometer network. This would allow someone to board a train in Kuwait City and travel to Muscat, Oman, passing through multiple countries. Speaking of Oman, let's move to a mega project in the middle of nowhere that has attracted controversy and profitability in equal measure. In the remote coastal town of Dhaka, Oman, something extraordinary is taking shape. A $10 billion oil refinery complex that represents one of the largest industrial investments in Omani history. But what makes this story fascinating isn't just the scale. It's why Oman is building a massive refinery at a time when the world is supposedly moving away from fossil fuels, and why they chose to build it in the middle of nowhere. Oman has been an oil producer since the 1960s, but unlike its Gulf neighbors with their massive reserves, Oman's oil fields are modest. The country produces about 1 million barrels per day, enough to generate significant revenue, but not enough to guarantee prosperity for generations. Omani officials recognized decades ago that the oil wouldn't last forever, and the country needed to extract maximum value from every barrel. The solution? Instead of just pumping crude oil and selling it, refine it into high-value products like gasoline, diesel, and petrochemicals that command much higher prices. The Duqm refinery project was conceived in the early 2000s as part of Oman's broader economic diversification strategy. The location choice, Duqm is 550 kilometers south of Muscat, far from Oman's main population centers and oil fields. But the location is actually strategic. The town sits on the Arabian Sea, outside the Strait of Hormuz, where a significant portion of the world's oil passes and where geopolitical tensions periodically flare. A refinery at Duqm can receive crude oil and export products without depending on Hormuz access. Moreover, Oman envisioned transforming Duqm into a major industrial hub. The government had already designated it as a special economic zone with tax incentives and streamlined regulations to attract investment. A world-class refinery would anchor industrial development, attracting related industries and supporting infrastructure. The original budget was set at approximately $6 billion when the project was approved in 2013, but this would prove wildly optimistic. Construction began in 2014 with extensive site preparation. The coastal location required building port facilities to receive crude oil deliveries and export refined products. The refinery complex itself would sprawl across several square kilometers, requiring massive earthworks to level the site and create foundations capable of supporting enormous processing units. Initial work focused on creating the basic infrastructure: roads, utilities, temporary housing for workers, and the port facilities. The refinery's design incorporated the latest technology to process both Omani crude and crude oil from other sources, making it capable of refining 230,000 barrels per day. More importantly, it was designed as a complex refinery with sophisticated processing units that could convert heavy crude oil into high-value light products. This flexibility means the refinery can process whatever crude oil is cheapest or most available, maximizing profitability. Construction ramped up in 2015 to 2016, with thousands of workers arriving at the remote site. At peak construction, over 20,000 people were working on the project, making it one of the largest construction sites in Oman. But problems emerged almost immediately. The remote location that offered strategic advantages created massive logistical challenges. Everything, from massive process towers to basic construction materials, had to be transported to Duqm. The nearest major port was hundreds of kilometers away. Building temporary housing and facilities for 20,000 workers in a town that previously had a population of a few thousand required essentially creating a new city. Technical challenges multiplied. Some of the refinery's processing units are among the largest ever built, requiring precision manufacturing and assembly. The coastal environment meant constant exposure to salt air that could corrode equipment. The extreme heat of Oman's summers, temperatures regularly exceed 45 degrees Celsius, made construction work brutally difficult and required special considerations for equipment that would operate in these conditions. By 2017, it was clear the original budget and timeline were unrealistic. The budget was revised upward to approximately $7 billion, then $8 billion, and eventually reached estimates of $10 billion. The completion date, originally set for 2017, was pushed to 2018, then 2020, then 2022. These delays and cost overruns are common in megaprojects, but the scale was still shocking. Several factors drove the cost increases. Global oil prices collapsed in 2014 to 2016, forcing Oman to secure additional financing under less favorable terms. Design changes were required as environmental regulations evolved. The sheer complexity of building such sophisticated infrastructure in a remote location proved more expensive than anticipated. And like virtually every megaproject globally, coordination among multiple contractors, suppliers, and stakeholders created inefficiencies and delays. The refinery finally began operations in 2023, nearly a decade after construction began, and 6 years behind the original schedule. The first crude oil was processed, and refined products began flowing. This marked a major milestone for Oman, representing the culmination of years of planning and construction. But starting operations doesn't mean the project is complete. As of early 2026, expansion and optimization work continues. Additional processing units are being commissioned, bringing the refinery toward its full design capacity. The integration of all systems, from crude oil receipt to product export, is being fine-tuned. The workforce is being trained to operate this complex facility efficiently and safely. The economics of the Duqm refinery are complex. At $10 billion, the capital cost is enormous, and generating returns that justify this investment will take decades. However, Oman's calculation isn't purely about financial returns. The refinery provides Oman with energy security. The country can now produce its own gasoline, diesel, and other petroleum products rather than importing them. It adds value to Omani crude oil, increasing revenue compared to simply exporting crude. The Duqm refinery has catalyzed broader development in the region. It has attracted other investors, including a Chinese industrial park, dry dock facilities, and plans for a petrochemical complex. The town of Duqm has been transformed from a fishing village into an emerging industrial city with modern housing, schools, hospitals, and infrastructure. Whether this development is sustainable, long-term remains uncertain, but the transformation is undeniable. In response to environmental criticism, Oman's position is pragmatic. The world will continue using petroleum products for decades, and Omani oil will be extracted and refined regardless. Better that it happens in a modern, efficient facility in Oman rather than being exported as crude oil for refining elsewhere. The Duqm refinery represents Oman's bet on an industrial future. At over $10 billion, it is one of the largest investments in Omani history. Over the next decade, it will either become a model of successful economic diversification or a cautionary tale about the risks of massive industrial megaprojects in an uncertain energy future. The Palm Jebel Ali is Dubai's third and largest palm-shaped island project, dwarfing even the famous Palm Jumeirah. With an estimated cost of $20 billion, Palm Jebel Ali represents Dubai's continued faith in artificial island development, despite lessons learned from partially failed projects like The World. The story of Palm Jebel Ali begins with the massive success of Palm Jumeirah, Dubai's first artificial palm island completed in the mid-2000s. Palm Jumeirah became an iconic address, home to luxury hotels like Atlantis the Palm, thousands of beachfront villas and apartments, and some of Dubai's most expensive real estate. The palm shape was visible from space, property values soared, and Dubai gained global recognition for audacious engineering. Encouraged by this success, Nakheel announced not one but two additional palm islands. Palm Jebel Ali would be built in the Jebel Ali area of Dubai, further south along the coast. Palm Dira would be constructed off the Dira district in northern Dubai. Together with Palm Jumeirah, these three islands would form a trio of palm-shaped developments that would define Dubai's coastline. Palm Jebel Ali was designed to be 50% larger than Palm Jumeirah, with a more complex structure. The design included the traditional palm trunk and fronds, but added additional features including water homes built on stilts, canals running through the development, and an 8-kilometer bridge connecting the island to the mainland. The project would create waterfront property for luxury villas, apartments, hotels, and entertainment venues. Construction began in 2002, shortly after Palm Jumeirah was underway. Dredging operations commenced, with ships sucking sand from the Gulf seabed and spraying it into carefully designed shapes. By 2007, the basic island shape was complete. Aerial photographs showed the distinctive palm outline emerging from the water. Breakwaters were constructed to protect the island from erosion. Infrastructure work began on the trunk section, including roads and utilities. The global financial crisis then devastated Dubai's real estate market, and Nakheel, the developer behind all three Palm Islands, faced financial collapse. Dubai's government had to orchestrate a bailout, and Nakheel's projects were reassessed. Palm Jebel Ali was put on hold. The island sat mostly complete in terms of land reclamation, but undeveloped, waiting for better economic conditions. For over a decade, Palm Jebel Ali remained in limbo. Aerial photographs from the 2000s showed the island's shape deteriorating slightly as erosion affected unprotected sections. The breakwaters required maintenance that wasn't always performed. The island became a curiosity, clearly visible from aircraft but obviously abandoned. In 2021, Dubai announced that Palm Jebel Ali would finally be developed. The revival came as part of Dubai's post-COVID economic recovery and renewed confidence in real estate markets. Nakheel released updated plans showing a completely reimagined development that incorporated lessons learned from Palm Jumeirah and changing market preferences. The new vision for Palm Jebel Ali includes over 80 hotels and resorts, 35 beach clubs, and thousands of residences. Unlike Palm Jumeirah, which focused heavily on villas, Palm Jebel Ali will include more hotels and entertainment venues targeting both residents and tourists. One innovative feature is the Palm Crown, a complex of hotels and entertainment venues at the center of the palm that will become a destination in itself. Construction restarted in 2022, beginning with infrastructure on the completed land areas. Roads are being built, utilities installed, and the island is being prepared for development. The approach differs from the original plan. Rather than developing the entire island at once, Nakheel is proceeding in phases, completing and selling sections before moving to the next. The $20 billion budget includes the original land reclamation costs, the infrastructure development, and the first phases of residential and hotel construction. As of early 2026, significant progress is visible on Palm Jebel Ali. The trunk section has active construction, with roads completed and building sites prepared. The first residential areas are under construction, with villas and low-rise apartments taking shape. The timeline for completion is ambitious. Nakheel has indicated that initial phases will be ready for occupancy by 2027 to 2028, with the full development completed over the following decade. However, questions remain. Dubai's hotel market is highly competitive, with new hotels opening constantly. Can Palm Jebel Ali's 80-plus hotels find enough guests to remain viable? The island's location in Jebel Ali, far from downtown Dubai and the airport, could be a disadvantage compared to more central locations. And broader questions about Dubai's real estate market persist. Is there genuinely sustainable demand for thousands more luxury properties? Or is this another boom that could bust? Environmental concerns have also been raised. Artificial islands disrupt natural coastal processes and marine ecosystems. The massive dredging operations affect seabeds and marine life. The Palm Jebel Ali's construction in the early 2000s caused environmental damage that took years to partially recover from. The revival of development raises these concerns again, though Nakheel insists modern construction methods and environmental controls minimize impact. When completed, Palm Jebel Ali will be visible from space like its predecessor, Palm Jumeirah, adding to Dubai's collection of megaprojects designed to capture global attention. Whether it becomes another success story or a cautionary tale about repeating past mistakes will be determined over the coming decade. From the artificial islands of Dubai, we go to Saudi Arabia, where an entirely new city is emerging from the desert. Jeddah, the kingdom's second-largest city and its main Red Sea port, has seen explosive growth over decades. By the early 2000s, the city's infrastructure was strained, housing was increasingly unaffordable, and traffic congestion was chronic. Rather than trying to retrofit Jeddah's existing urban fabric, Saudi planners decided to build an entirely new city adjacent to it. Jeddah Economic City was announced as part of a new push to create new cities along the Red Sea. The Jeddah project would be the centerpiece of the development, focusing on trade, logistics, industry, and residential communities. The location was chosen strategically. The site lies about 50 kilometers north of central Jeddah, along the Red Sea coast with access to existing highways and near the planned Jeddah-Mecca Expressway. The area was largely undeveloped, mostly desert and some agricultural land, providing a blank canvas for creating a modern city according to 21st century planning principles. The master plan for Jeddah Economic City is ambitious. The development covers 173 square kilometers, roughly the size of Washington, D.C. At full build-out, The city is designed to house 1.4 million residents and create 1 million jobs. The city is organized into distinct zones: a seaport and logistics area, industrial zones, commercial districts, residential neighborhoods, and recreational spaces including beaches and parks. The centerpiece and the most visible element is the Jeddah Tower, originally called Kingdom Tower. This skyscraper, designed to exceed 1,000 meters in height, would become the world's tallest building and the iconic symbol of Jeddah Economic City. Though the tower's construction has faced delays and remains incomplete as of 2026, it represents the ambition and scale of the broader city project. Construction on Jeddah Economic City infrastructure began in 2010. Initial work focused on basic infrastructure, roads, utilities, and port facilities. The King Abdullah Port, a critical component of the development, was completed and opened in 2013. This modern container port gives Jeddah Economic City direct access to global shipping lanes, essential for the logistics and trade focus of the development. The port's success has been one of the project's bright spots. King Abdullah Port has grown rapidly, handling increasing volumes of container traffic and competing effectively with established regional ports. The port has attracted logistics companies, warehousing operations, and light industrial facilities that use the port for imports and exports. This created an economic foundation for the broader city development. Residential development proceeded in phases. The first neighborhoods, completed in the mid-2000s, included thousands of housing units ranging from apartments to villas. These were marketed to Saudi families looking for affordable housing near Jeddah, but frustrated by the main city's high costs and congestion. Industrial zones were established with incentives to attract manufacturers and logistics companies. Several companies built facilities in Jeddah Economic City, attracted by the port access, available land, and government incentives. Light manufacturing, particularly for export-oriented industries, found the location appealing. However, attracting heavy industry proved more challenging given Saudi Arabia's high energy costs compared to some regional competitors. The 2017 to 2018 period brought significant challenges. The Saudi government's fiscal situation was pressured by lower oil prices, and major projects across the kingdom faced budget constraints. The broader Economic Cities initiative was reassessed, and several planned cities were scaled back or put on hold. Jeddah Economic City continued, but with reduced government funding and a more pragmatic timeline. The project also faced the challenge that creating a successful city requires more than just buildings and infrastructure. Cities need jobs to attract residents, but employers want to locate where workers already live. Jeddah Economic City addressed this partly through the port and industrial zones, which created jobs, but attracting enough economic activity to support 1.4 million residents remained aspirational. Saudi Arabia's Vision 2030 initiative, launched in 2016, provided renewed context and support for Jeddah Economic City. Vision 2030 emphasizes economic diversification, private sector job creation, and improving quality of life, all goals that Jeddah Economic City advances. The project was repositioned as a key Vision 2030 initiative, potentially unlocking additional funding and government support. As of early 2026, Jeddah Economic City is partially developed and operational, but far from the original vision. The King Abdullah Port is thriving and expanding. Several residential neighborhoods are complete with thousands of residents. Industrial zones have attracted some tenants, though occupancy rates vary. The beachfront areas have seen development, including hotels and recreational facilities serving both residents and visitors from Jeddah. However, large portions of the 173 square kilometer site remain undeveloped. Many planned neighborhoods exist only on paper. The commercial core that would create an urban center with offices, retail, and cultural facilities is only beginning to take shape. And the Jeddah Tower, which would serve as the ultimate landmark and symbol, remains an unfinished structure after years of construction delays. The vision of a new city of 1.4 million residents remains distant, with the current population reaching just over 100,000 people. Whether the city will ever reach its planned scale depends on Saudi Arabia's continued economic growth, the success of Vision 2030, and whether Jeddah Economic City can attract businesses and residents needed to reach critical mass. For the biggest megaproject on today's video, we cross continents yet again to move to northern Africa. In one of the driest regions on Earth, Libya accomplished something that seems impossible, creating a river, not a natural river, but a man-made system that pumps ancient water from deep beneath the Sahara Desert and transports it hundreds of kilometers to Libya's coastal cities. The Great Man-Made River is arguably the world's largest irrigation project, a $25 billion engineering marvel that provides 70% of Libya's fresh water, and a megaproject that tells the story of Libya's past ambitions and current struggles. To understand why Libya built this extraordinary project, you need to understand Libya's water crisis. Libya is one of the most arid countries on Earth, with over 90% of its territory covered by the Sahara Desert. Rainfall is scarce and unreliable. Coastal cities like Tripoli and Benghazi relied on aquifers that were being depleted faster than they could recharge. As Libya's population grew in the mid-20th century, water scarcity became an existential threat. In the 1950s, while searching for oil in the Sahara Desert, geologists made an unexpected discovery: massive aquifers containing fresh water deep underground. These aquifers were formed thousands of years ago when the Sahara was wetter, and they hold an estimated 35,000 cubic kilometers of water, though only a fraction is extractable. This fossil water doesn't replenish. Once used, it's gone. But Libya's leadership saw an opportunity: pump this ancient water to the coast and solve the water crisis. Muammar Gaddafi, who ruled Libya from 1969 to 2011, championed the Great Man-Made River as a signature project of his regime. He called it the eighth wonder of the world and positioned it as a gift to the Libyan people and Africa. The project would demonstrate Libya's technological capability and improve millions of Libyans' lives. Planning began in the late 1970s with feasibility studies conducted by international engineering firms. The plan called for drilling hundreds of wells deep into the Sahara aquifers, then constructing enormous pipelines to transport water hundreds of kilometers to coastal cities. The system would be built in phases, with each phase adding new wells and pipelines to expand coverage. Construction began in 1984 on Phase 1, connecting wells in the Tazerbo and Sarir areas to Benghazi and surrounding cities. The engineering challenges were immense. The wells had to be drilled 450 to 500 meters deep to reach the aquifers. The pipelines, each pipe 4 meters in diameter and made of pre-stressed concrete, had to cross hundreds of kilometers of desert. These pipes were manufactured in Libya at purpose-built factories with over 500,000 pipe sections eventually produced for the entire system. The construction process was remarkable. In the desert, workers excavated trenches for the pipes, then installed them section by section. Each pipe section weighed several tons and required specialized equipment to position. The pipes were then buried to protect them from temperature extremes and potential damage. Pump stations were built at intervals to maintain water pressure across the vast distances. Phase 1 was completed in 1991, delivering 1 million cubic meters of water daily to Benghazi. The impact was immediate. Water quality improved, availability increased, and agriculture expanded in areas that previously struggled. Encouraged by this success, Libya pushed forward with additional phases. Phase 2, completed in 1996, connected the Jebel Hassouna area to Tripoli and surrounding cities. Phase 3 added connections to the Kufra and Tazerbo areas. Phase 4 and 5 expanded the network further. By the early 2000s, the Great Man-Made River system consisted of over 4,000 kilometers of pipelines, more than 1,300 wells, and numerous reservoirs and pump stations. The system was delivering approximately 6.5 million cubic meters of water daily to Libya's coastal cities. The total cost reached approximately $25 billion, an enormous sum, particularly for a country of Libya's size. The funding came from Libya's oil revenues during a period when oil prices were relatively high and Libya's economy was stronger. International contractors and engineers were involved, but Libya insisted on developing local expertise and manufacturing capacity for the pipes and equipment. For Libya, the project was transformative. Cities that had struggled with water shortages now had abundant clean water. Agricultural development expanded, with previously barren areas cultivated using the desert water. The project employed thousands of Libyans and became a source of national pride. From a purely technical perspective, the Great Man-Made River was an engineering success. Then came 2011. The Libyan civil war erupted, Gaddafi's regime fell, and Libya descended into chaos that continues to this day. The Great Man-Made River became both a casualty and a lifeline during the conflict. Several sections of pipeline were damaged by fighting. Pump stations lost power. Maintenance became difficult as the country fragmented into competing factions. Yet the system continued operating, testament to its robust design and the efforts of engineers and workers who maintained it despite extraordinary circumstances. Water continued flowing to Tripoli, Benghazi, and other cities even as the country descended into conflict. This highlighted the system's critical importance. Without it, Libya's cities would face catastrophic water shortages. As of 2026, the Great Man-Made River continues operating but faces serious challenges. Maintenance has been deferred due to funding shortages and security concerns. Some sections need repairs, but accessing them in contested areas is difficult. The system operates below its design capacity due to damaged infrastructure and power supply issues. There are concerns about water quality in some areas due to inadequate maintenance of treatment facilities. There are also growing concerns about sustainability. The fossil water in the aquifers is finite and non-renewable. Studies suggest that at current extraction rates, some aquifers might be depleted within 50 to 100 years. Alternative water sources, particularly desalination, may eventually be needed, but these are expensive, and Libya's current political and economic situation makes large new infrastructure investments unlikely. The Great Man-Made River was built during Gaddafi's rule, funded by oil revenues during relatively prosperous times, and it relies on a finite resource that will eventually run dry, meaning Libya hasn't actually solved its water crisis permanently. It's just delayed the problem by several decades. The Great Man-Made River remains operational in 2026, continuing to deliver water to millions of Libyans despite the country's ongoing challenges. Whether it will survive another 25 years and whether Libya will find sustainable water solutions to replace or supplement it remains uncertain. But for now, this $25 billion river in the desert stands as one of Africa's most ambitious engineering projects, a testament to human ingenuity and the extraordinary lengths nations will go to secure the most fundamental resource, fresh water. Which of these megaprojects impressed you the most? Let us know in the comments below. If you enjoyed this video, make sure to watch the part 1 of our series on the biggest megaprojects in Arabia. Thanks for watching, and we'll see you in the next video.